This is Earth's most dangerous neodymium magnet. Its strength is so intense that when two of these magnets are brought close together, they collide with such force and speed that they can shatter on impact. Their attraction is so dangerous that if any object comes between them, it gets crushed to pieces. Even electronic devices can get damaged. If a human hand accidentally gets caught between them, it would crush it, applying such immense pressure that bones could break. And once these powerful magnets connect, separating them is almost impossible. But the question is, where does a magnet get such power? What kind of force in a piece of metal makes it so magnetic? And how is this magnet actually made? In today's video, let's learn about magnetism. I'm Junction 2, Tech Explained, Story Channel. You're on a channel about healthy and scientific knowledge than knowledge. If you're new here, be sure to subscribe. I bring you such informative videos because in this world, knowledge is everything. Magnets are amazing objects that create an invisible magnetic field around them. Any magnetic object entering this area is instantly attracted and sticks to the magnet. Magnetic objects are those attracted to magnets like iron, nickel, and cobalt. Non-magnetic objects like plastic, wood, or cloth won't budge near a magnet. So, how is a magnet made? How does it work? Where does its attractive power come from? Let's go inside an atom to understand. Inside an atom at the subatomic level, we find electrons, protons, and neutrons. The nucleus, made of protons and neutrons, spins on its axis, while electrons orbit and also spin on their own axis. This spinning of electrons creates tiny magnetic fields around them. If these tiny forces align in the same direction, the material becomes a magnet. However, in most metals, this doesn't happen. In non-ferromagnetic metals, not iron, nickel, or cobalt. The tiny magnetic fields from electrons point in different directions and cancel each other out. That's why gold, silver, brass, and copper aren't magnetic. But in iron, nickel, and cobalt, some electrons are unpaired and move in the same direction. Their magnetic fields don't cancel, resulting in strong magnetic properties, making them ferromagnetic. They are attracted to magnets and can become magnets themselves. Adding other elements can create even stronger magnets like alnico or the world's most powerful neodymium magnets. How is a magnet made? One simple way is to rub an iron object, like a nail, in one direction with a powerful magnet. This aligns its domains, making it magnetic. Another method uses machines. A non-magnetic piece of iron is placed inside a coil with an electric current, generating a strong magnetic field that forces all domains to align in one direction. The longer and stronger the exposure, the better the alignment, creating a permanent magnet. Another technique involves hammering or vibrating the material within a magnetic field to help domains align. The strength of a magnet depends on the percentage of domains perfectly aligned. The higher the alignment, the stronger the magnet. But how can you destroy a magnet's power? Heating a magnet excessively causes its atoms to vibrate violently, scrambling the domain alignment and permanently losing its magnetism. For iron, this happens around 770 degrees Celsius, exposing it to a strong opposing magnetic field. Or long-term environmental stress can also weaken or destroy its magnetism. When a magnet's thin needle is suspended in air, it points north-south. The end pointing north is the North Pole, and the south pointing end is the South Pole. In an experiment, bringing two like poles north-north or south-south close causes repulsion. They push apart. Opposite poles, north-south, attract and stick together. This happens because the magnetic field flows from the north to the south pole within the magnet, causing a clash when like poles meet. Interestingly, if you cut a magnet in half, you don't destroy its magnetism. Instead, you get two smaller magnets, each with its own north and south poles at the cut ends. Did you know Earth itself behaves like a magnet? It's believed Earth's core is made of iron and nickel, giving it its own vast magnetic field. Some people confuse gravity and magnetism. Gravity works on mass. It attracts objects with mass toward each other, like us, toward Earth. Magnetism only affects specific materials like iron, nickel, cobalt, and only when a strong magnetic force is nearby. So, we and everything on Earth are here due to gravity, not magnetism. So, friends, how did you like this video? Let us know in the comment box. For healthy and scientific knowledge, join us at the Knowledge because knowledge is everything. Have a wonderful day. Take care. If this story resonated with you, please subscribe, like, share, and comment below. Your thoughts encourage the creation of more stories like this. Thank you for listening. Until next time.